Welcome to this explainer. Today, we're unpacking the Model Context Protocol, or MCP. This is, without a doubt, a definitive paradigm shift in how we scale AI agent capabilities. If you have ever dealt with the absolute nightmare of integrating new tools into your AI workflows, the endless custom scripts, those incredibly brittle API connections, well, this is exactly the breakthrough you and your team have been waiting for. Let's get right into it. To really grasp why this is so revolutionary, I want you to imagine the scene at the September 2026 Argus Platform Engineering All-Hands meeting. Niam, a staff platform engineer, stands up and demonstrates an AI agent executing a massive, highly complex, enhanced due diligence compliance check. And the agent pulls the whole thing off entirely on its own in just 4 minutes and 11 seconds. It's incredibly impressive. Even better, it seamlessly utilizes 2 brand new tools her team literally just shipped that very week. Then, she pulls up the commit history and asks the room how much code had to be altered in the agent's repository to achieve this integration. The answer? 0. Absolutely 0 lines of code were changed. Not a single hard-coded integration was needed because the agent dynamically rediscovered the updated tool catalog the exact moment its session started. Here's our roadmap for how we get to that zero-code magic. First, the integration problem. Second, the LSP breakthrough. Third, the 4 core primitives. Fourth, the discovery handshake. And finally, security and pitfalls.
Part 1. The integration problem. Escaping the tool list explosion.
Before November 2024, connecting tools to agents was a massive, massive headache. It required this custom M times N integration matrix. Basically, if you had M agents and N tools, every single pair needed its own manual integration. Adding just one new tool meant you had to completely redeploy every single agent that might possibly use it. If you've ever had to maintain that kind of matrix, you know it is a special kind of deployment torture. But MCP brilliantly collapses all of that into a simple M plus N additive equation. You build the tool once, and boom, it is instantly available to all compatible clients.
Moving to Part 2, the conceptual breakthrough, a unifying standard.
Now, thinking back to that all-hands meeting we just talked about, when the team realized what they had just witnessed, someone in the back of the room perfectly captured why this matters. They literally said out loud, "Oh, this is the LSP moment." They realized that what the language server protocol did for text editors back in 2016 is exactly what MCP is doing right now for AI agents. Before LSP, every single code editor needed a totally custom integration for every programming language. After LSP, any editor could speak to any language server. MCP is that exact same unifying standard, but for agents and their tools.
So the crucial takeaway here is that MCP enables what we call the late binding of tools to agents. Think of late binding like plugging in a USB drive. Your computer doesn't need to be pre-programmed for that exact specific drive, right? It just figures it out the moment you plug it in. This dynamic capability negotiation layer completely eliminates the need to integrate and redeploy your agent ahead of time. The host and the tool source don't even need to know about each other until the session actually starts.
Part 3, the technical core, defining the protocol.
Let's look at the 4 foundational MCP primitives. First, we have tools, which are the actions the agent can invoke. Second, are resources, which provide read-only data. Third, prompts, which are reusable templates surfaced to users. And fourth, sampling. Now, sampling is incredibly special. With sampling, the server can actually ask the AI brain questions back. Traditional REST APIs? Those are one-way streets. But this is a genuine two-way conversation.
Let's ground this in reality by looking at a specific tool Niam built at Argus. The action is checking an entity against an SDN, or sanctions list. To publish this tool, it requires a very strict structure. It needs a verb-noun name. It absolutely needs a clear description because that is what the agent actually reads to decide when to pick the tool. It needs a typed JSON input schema, and crucially, it strictly adheres to 4 security metadata axes, things like blast radius, handling sensitive PII, and item potency, ensuring the agent doesn't accidentally trigger the exact same action twice.
Now you might be wondering, why not just use an OpenAPI endpoint for this tool? Well, while OpenAPI statically describes an existing interface, MCP prescribes a dynamic bidirectional transport layer. Sure, you can auto-generate an MCP server from an OpenAPI doc, but you cannot auto-generate dynamic discovery, capability negotiation, or that awesome bidirectional sampling we just talked about. It's a whole different ballgame.
Let's test this logic together. If you were building a second tool, say to look up beneficial ownership, how would you expose the read-only Open Corporates data snapshot to the agent? Remember, we need to separate the action from the data. Take a second to think about how you'd configure that.
The answer is you would configure a resource primitive. You'd use a custom URI scheme, like opencorporates://, a specific MIME type, and a refresh cadence, like 7 days, since ownership data usually changes pretty slowly. This separation is the true discipline of the protocol. It keeps the action perfectly isolated from the slow-moving data.
Part 4. The mechanics. How agents learn.
Let's look exactly at how the agent physically discovers these tools at runtime through a sequential discovery handshake. Step 1, the agent opens a session. Step 2, it sends an initialization request. Step 3, the server returns its capabilities. Then, the client explicitly requests the lists of tools, resources, and prompts. And finally, the server returns the fully typed manifest. This is where the magic happens. The agent's base prompt never has to change. It literally just wakes up, reads the menu, and knows exactly what it can do.
Part 5. Security and pitfalls guarding the protocol. We have to talk about security, because this is a massive point of failure for some teams. It is absolutely vital to remember that MCP is just a transport layer. It is not a replacement for your least privileged design frameworks or your 4-axis security rules. When it comes to OAuth, the specs are clear, but they are intense. For public servers, you're looking at OAuth 2.1 with PKCE. But if you're building internally, like Naeem's team at Argus, a tightly scoped, short-lived service account JWT is your best friend. And for the absolute most sensitive data, that's when you step up to mutual TLS. And this brings us to a major pitfall. MCP is highly opinionated about its naming conventions. If you fall back on old habits and use the word parameters instead of MCP strict input schema or path instead of URI, your tools are just going to silently fail. The agent will completely ignore them, and you will be pulling your hair out. You absolutely must adhere to the exact MCP schema rules. No shortcuts. Despite that strictness, the success of this opinionated approach is undeniable. Anthropic released this as open source in November 2024. By December 2025, it was donated to the Linux Foundation, with founding members like Microsoft, Google, and AWS jumping on board. By 2026, we were seeing over 10,000 active production servers utilizing MCIP. It has truly become community-governed open infrastructure. It's a real game changer.
To wrap up this explainer, I want to leave you with a provocative thought to consider for your own platforms. We've seen the incredible power of late binding and dynamic discovery today. But in what specific scenarios is dynamic runtime discovery actually the wrong choice? Where would MCP fail your architecture, and what static integration would you rely on instead? Think about that as you design your next workflow. Thanks for joining me.